Alright, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing. Well, today I'm actually planning on just reading up on this. First of all, I'm gonna read up on span, which is where is it? It is here, I think. Yeah. So I'm gonna read up on span. There's a little there's a well, not a little one. There's like a big blog post explaining a lot about span. It seems to me like span can be helpful to me in certain ways. I just need to figure out in what ways exactly, and like if I do need to. Oh, good. They're also covering memory here. So yeah, I need to figure out in what ways I can use span in my workflow that would make it better than just using a regular array. I don't know if I should spend time reading the entire thing. Oh, just a minute. Yeah, so I don't know if I should spend time reading the entire thing on stream. I'm definitely going to read the entire thing like on my own time. But right now, the idea is to get enough knowledge to be able to start using span. I also haven't used buffer.blockcopy yet. I'm going to be using this. It seems like buffer.blockcopy is slightly more performant than array.copy. And like if I'm able to get that extra bit of performance, I think I'll take it. Though, I mean, I need to see if I absolutely need the array copy operation, because the thing is, I am going to be receiving the data. So like, okay, let me go back to, before I started today's stream, I wasn't sure, like it didn't occur to me that, oh shit, okay, I'm going to be streaming again today. But yesterday I streamed for like 4 hours or close to 4 hours. And usually after streaming for that long, I have to give my voice some rest, at least one day of rest, because if I stream the next day, I can't usually go for very long. But let's see how long I'm able to. That's also one of the reasons why I was okay with starting a little bit late today. So I can I'm probably not going to go for too long, at least not as long as yesterday. But let's see how long I'm able to last before I start to feel the stress, because like I'm already feeling like the stress in the vocal cords a little bit. But like we can keep going. Okay. So let's think about what exactly we're going to be doing here. So we're going to receive the raw message bytes, right? Do I have that to-do list? Oh shit, I forgot about this to-do list. I need to make changes here and there to make sure that the DVTMP message protocol is now using an enum instead of a string. Yeah, I need to make this good thing I wrote this stuff down. Okay, so we're gonna have the magic number, we'll have the payload size, and we'll have the payload data itself. Right? Something I could do is I could open up a separate script. Oh, you know what? No. I could pack data on the same script and then unpack that same data again. That would work. But like I would prefer to work with like live data, because like the data is like, it's right there, right? I just need to turn on my, I just need to like run the Python script, and it's gonna start sending the data. Now, the thing is, I haven't written the packing logic within the Python script, so I still need to work on the packing logic there. So I can either work on the logic there or work on it here for testing purposes. It would be the same thing. I'd also worked on... I'd also created these classes, which I'm not entirely sure I'm going to need now. I mean, I might need them because, like... Okay, we have landmark, for example. I'm going to be receiving a list of landmarks. That list of landmarks is going to be basically... Like, it's... Now JSON is not involved, right? So I don't need to do this. Before, I was doing this mainly so that it has a container. There's a class that has a container for the array. But like now I don't need to do that because I'm not using JSON for this purpose. I'm manually unpacking the data. So any data that I'm getting, I'm just going to create an array and like place everything in that. Which I'm wondering if I should turn this into a struct rather than a class at this point. I'm wondering if that would help me avoid garbage collection to a certain extent. Because like I'm not going to be passing... well, I'll also have to take into account whether or not I'm going to be passing data around here and there. I need to read up on like the garbage collection for structs versus a class before I do this. This seems like it would be like a micro optimization. You know what? Hold on. Quick Google search. Actually, I'm going to switch to BRB real quick. And just a second. Okay, so C# struct versus class performance. There's probably going to be like a bunch of threads on Stack Overflow for this. And it seems like somebody wrote an article on Medium as well. Okay, there's on Stack Overflow. There's performance and memory optimization for this. Okay. Struct versus class performance. Design focus. Okay. Are structs faster than classes? Okay. Why are structs so much faster? Okay. Because like it comes down to like, okay, a struct is usually a value type and a class is a reference type, but it's not just that simple. Like what exactly happens, how this impacts your performance, it's not as simple as, oh, this is a struct, it's going to be this, that's a class, that's going to be that. It really depends on the situation, but I need to get as much info as I can to be able to make my decisions when it comes to performance optimization. Okay, structs are to be used only for relatively small data structures that should have value-like behavior. Okay. Microsoft has... I think I've read those before. This is one of those situations where like I've read... Why are you asking me to download Visual Studio, dude? How did we get here? Okay, fine, cool. Do not define a structure unless the type has all of the following characteristics. It logically represents a single value, similar to primitive types. That is true in my case. It has an instance size small... Wait, really? It has an instance size smaller than 16 bytes. It is immutable. It will not have to be boxed frequently. Your type breaks the first two guidelines. I think mine does break the first two guidelines because, dude, I'm working with floats. A float would be, what, 5 bytes, I believe? In C#, I think it's 5 bytes. I think on the Python side it is 5 bytes. I don't remember. Hold on. C# float size. No, it's 4 bytes. Where did I get 5 from? Hold on. Just a second. Where did I get 5 from? Python float size. It's 64. So I'd gotten 5 from somewhere. I don't remember where I got from. Maybe I was just mistaken. But okay, on the C sharp side, a float is 4 bytes. Now, if one float is 4 bytes and I have X, Y, Z, oh, that's where I got 5 from because I have 5 of them. Okay, so it wasn't 5 bytes. In my calculation, I was probably doing 4 into 5. So that's 20 bytes in total because we have X, Y, Z, visibility, and presence. These are the 5 fields that are going to be sent, or, well, packed and unpacked. So I'm like 4 bytes above. I don't think 4 bytes above. I don't think 4 bytes above is gonna matter. The thing is, though, it's not just that one instance. It's gonna be an array of those instances. So, like, is there a more performant way that I can do that? Though, is it really gonna be performant, or, well, is it really gonna be worth taking the headache of doing that performance optimization? Just a second, guys. Give me a second, guys. All right. Okay, so back to what we were doing. Great, cool. So, yeah, I don't know if, like, at a certain point I'm just micro optimizing because, like, I try to be careful even when using arrays, but then, like, it's at what point are you micro optimizing too much when you're trying to be careful of, I mean, what else am I supposed to do? I need to have an array, right? That's the only way that I can store, like, multiple values. So then, like, I'll need at least that level of, I'm gonna need to be able to use arrays. So, like, I feel like that's the point where I'm looking too deep into it, to the point where it doesn't really benefit me as much, but just wastes my time. I think so. Okay, they mentioned something about boxing. Doesn't that basically mean that, like, you'd be able to typecast it? Let's open that up. Boxing and unboxing. Yeah. The following line boxes I. Okay. All right. Boxing is the process of converting a value type to the object type or to any interface type implemented by this value type. When the common language runtime boxes a value type, it wraps the value inside a system.object instance and stores it on the managed heap. Okay, so it's specifically, no, wait, when it boxes a value type, it wraps so and so. So, like, what happens when I'm doing typecasting? Is the variable getting stored wait, no, I need to Google this. Hold on. C# typecasting performance. How expensive is casting an object? Because, like, I do end up in situations where, well, okay, to be fair, I'm typecasting between primitive types, between the primitives that they have. So I wonder if there's already some performance optimization in place for doing that, or if they already have like a more performance friendly way of doing that. It may be measurable if it's done billions of times with very little other work. I don't know whether the CLR will effectively cache the fact that the cast worked, so it doesn't need to do it again. If it doesn't do so now, it might do so in a later release. This is from 2009. Okay. It might do so in 64-bit JIT, but not in the 32-bit. Okay. Personally, I like the readability of the second form more, and that's more important by far. What's the second form? Okay. Oh, okay. All right. You know what? Okay, I don't need to worry about this. I don't think I need to worry about this too much, because, like, the person is saying that unless you're doing it like in a massive amount, you're not necessarily going to notice like a massive difference. So I'm going to let this one go, and we're going to carry on reading this. So okay, I don't need to worry too much about boxing right now. So we're not gonna look too deep into that. Okay, it isn't as simple as that. You need to describe the behavior. For example, a struct will copy itself as soon as you like. So in some ways, they can consume more memory. However, an array of structs as a raw data dump can avoid a very small object header and an extra dereference, so it can have efficiencies. A bigger issue, though, is in how you conceptualize them. An employee is not a value. If that's true, so that might be a class, right? Well, I mean, okay, no, it depends, right? Well, an employee could be a group of values, right? So okay, let's go based on this person's thing. Okay. Does that mean I should now have 2 employees? It probably doesn't. Oh, they mean that do you want to pass it by value or by reference? I think that's what they were getting at. Now, what if I change temp.name? Well, if you change temp.name and employee is value type, then temp is going to have its own value and emp is going to have its own value. Well, each of them are going to have their own names, but like if it's a class, then it's passed by reference. And so if you change the... Hold on. Yeah, it's a reference. I stopped myself there for a second because I was trying to remember if that does actually happen. Because like it's passed by reference, right? You're assigning the reference. You're not creating a new instance. And so If it is passed by reference, then changing the name field in EMP or TMP, it's going to have the same effect on both of them. Like, it's going to affect both of them. Whether this impacts, okay, this person is probably saying the same thing as well. Whether this impacts EMP depends on whether it is a struct or a class. I wager it should be class here. I also propose that the struct should almost always be immutable to avoid this type of data loss, scenario. There is case for mutable structs, but it is often used incorrectly that it is so often used incorrectly that I don't want to accidentally encourage you to do that. Other issues arise with encapsulation with structs. Consider that an employee has a manager. Is this possible? Okay, this is going a little away from what I was trying to find out. Okay, so here. This person asked a question. So they are asking about using it as a data store. Now, okay, in my case, this specific thing, I'm not going to be operating. Well, okay, I might be operating on it, but like mainly it's going to be storing data. It's going to get the data. It's going to store unpacked data. So further from that point, I'm not really doing too much to it. I'm also not passing that array around. I'm not passing the data around. So whether it's a reference type or a value type, I guess the only difference I would make there is like it's a value type and then it just gets stored on the stack instead of the heap. So then that's one less like garbage collection, right? But then the array I think is going to be stored on the heap, right? That's going to get garbage collected, I believe. But I think that's going to be much smaller. I think that's going to be a much smaller garbage collection. Also, it's worth noting that I believe, and this is like, I'm looking into this from something that I learned about CPU prefetch, the CPU prefetch cache. And like, I mean, that doesn't like very heavily apply here, but like the idea is that like, okay, the data is laid out linearly if it's value types. So they can like place it one after the other, like linearly. But if it's a reference type, then the data is usually stored somewhere else and then you store a reference to that. If it's an array of them, you're storing references to other memory locations. Whereas if it's a value type, then you're storing all the values linearly in that like one location, and then you have a pointer to the array itself. Like the array is pointing to that one memory location. So I wonder, okay, maybe I should make this a struct. Okay, I would make the choice based on the following criteria. Reference type versus value type semantics. If two objects are only equal if they are the same object, it indicates reference type semantics greater than or equal to class. Oh, wait, no, I'm not understanding what this person is trying to say. Give me a second, I need to hydrate. Okay. Memory footprint of the object. You know what I need to do? One of these days I need to go back and read the fundamentals of how memory allocation is done. They actually had, I have read this, and it's one of those things where I end up having to read it every once in a while again, because there's certain details in there that I don't necessarily always have to worry about, and so I just forget about them after some time. So every once in a while I have to go back and read it. Okay. C sharp, memory allocation, I think. Blog. Okay, let's remove blog. Because I'm looking for the thing on... Wait, reduce memory allocations using new C sharp features? Which new C sharp features? Pass and return by reference. Variables in C sharp store values. Instruct types. It's the contents of an instance of the type. In class types, the value is a reference to a block of memory that stores an instance of the type. Adding the ref modifier means that the variable stores the reference to the value. In struct types, the reference points to the storage containing the value. In class types, the reference points to the storage containing the reference. Oh, wow. So it's a reference to a reference? Right, hold on. Performance engineering. And yeah, maybe I should bring it up here so I can read it here. Just a second. Just gonna look this up. C sharp memory management, not memory allocation. Okay, so they have one here. I'm looking for another one on the C sharp docs site. So let's do docs.microsoft.com. Memory allocation, memory management. Okay. This is not helping, so let's get rid of that. C sharp memory management. They had like a very helpful thing. This one is for ASP.NET Core. Not what I'm looking for. Okay. Okay. All right. Okay, let's try stack versus heap. Like that gives a specific thing where stack and heap. Stack and heap docs. Allocating on the stack or on the heap. Okay, so there's a .NET blog post for that. So I can open that up. And I think we should be good. Alright, so I can go back. Great. Awesome. Let's also go back to the music thing and just make sure that that's still running. By the way, shout out to Machine Supremacy. Go check them out. Pretty awesome band, pretty awesome music. Especially if you enjoy video game inspired music, you'll like their stuff. Okay. Right. So, reduce memory allocations, and here is this blog post as well. This is from 2015, but I'm pretty sure a bunch of the stuff still applies. Okay. A recent discussion prompted me to write this blog entry. The question there is whether when should I allocate something on the stack versus on the heap. I searched around and there are plenty of articles that somebody was explaining the thing. There was an article that I'm just not able to find it here right now. Somebody had made an article on actually multiple, not just one. But I think they had done the thing on garbage collection. So let me just open that up as well. Garbage collector, fundamentals of garbage collection. That's not what I'm looking for. .NET garbage collection, memory management. Okay. Memory management, garbage collector, dev blog. I don't know if it's in the dev blog or somewhere else. Somebody had made a very helpful thing. Garbage collection at food courts. Okay, let's open that up. Let's see what that's all. Let's see what that's all about. All right, so I have a couple of these open now. So we're gonna go through a bunch of these right now. Okay, so where's that blog post that I was looking at? Oh, this one is done by the same person, but like 5 years later. Okay. I searched around and there are plenty of articles that talk about what gets allocated on the stack versus on the heap, but not how you should decide what to allocate on the stack versus the heap. It makes sense to understand the implications of allocating on the stack versus on the heap in order to make the right decisions, because as with most performance advice, there's no one rule fits all. That makes sense. Often the right approach is to understand what things mean, then see the consequences they have in your specific context. This is meant to help you understand. Okay, there's an ad playing, so I'm gonna hydrate and I'll see you in 30 seconds. Okay, welcome back. By the way, since I'm doing a bunch of reading, what I'm thinking is, let me just bring up this instead. So let's disable this and disable this, and now we can just read this right here instead of looking at the code window, which is not doing a whole lot right now. So I'm going to be doing a bunch of reading now, so you know, might as well. Okay, so where was I? It makes sense to understand the implications of allocating. Oh, okay. This is meant to help you understand these implications better so that you can think how they fit into your scenario. You already know there are syntactic things that you can do with references that you can't do with structs, like you can't inherit from a struct, so I won't focus on those here. I don't think I've ever even tried inheriting from a struct. Like, I don't think I've ever been faced with that kind of situation, but good to know that you can't inherit from a struct. It's something good to keep in mind. This is about how you make decisions based on performance. Okay, cool. All right. At the allocation time, it's best, in the best case, heap allocations can be as fast as stack allocations. They both advance a pointer and clear memory they hand out. And clear memory they hand out. They advance a pointer and clear memory they hand out. Okay. Of course, stack has more chances to have better locality, to have better locality. And heap allocations can also be more expensive when we use the free list in Gen 0. But since we only go to the GC for memory every few kilobytes, the efficiency of using the free list shouldn't be too bad. If I use 100 cycles as an approximation of reading the free list and 1 cycle to clear 1 byte equals. All right, moving on. There's an important point for which small allocations there's an important point which is for small allocations you can save the 2-pointer sized words if you allocate on the stack. If the object is greater than 2k, then the 2-pointer size is also less than 1%. So I would say after 2k, the advantage of space saving for stack starts to diminish. Okay. Oh, that's interesting. Also, since struct is embedded, if you're allocating an array of struct, the payload is just struct size multiplied by the number of elements, whereas an array of class. Oh, yeah, so the struct size would then, wait, the payload size would then be bigger, but then for a class, I think the payload size would be the reference size multiplied by the elements, right? So yeah, the pointer size multiplied by the number of elements, because each element is a pointer that points to an instance. There you go. Plus space each class instance takes up. Okay. However, the consequences of stack and heap allocations can be very different. For the stack, we have a very limited amount of virtual address space on the stack. No, for stack, we have a very limited amount of virtual address space on the stack. It's not uncommon to see stacks with 256 frames these days, which means each frame gets 4K in case of the 1 MB stack size. Of course, most frames don't consume nearly 4K. Note, I used to mention specific stack sizes here, but I've since removed it. Apparently my memory was incorrect, and my understanding of how they edited this later on. How the stack size is set was also insufficient. A few years ago, we made a change to reduce our stack size to be half of the default size. Okay, alright, it's fine. Note, you can also stack alloc. I have not used this function. I've seen this function pop up before, but I've never used it myself. Let me just look it up real quick. Stack alloc. Is this an unsafe thing, or... Oh, it's only relevant in unsafe code. For managed code, you can't decide where to allocate the data. Value types are allocated on the stack. Okay. Okay, so this requires unsafe. Oh, hold up. This is interesting. A stack alloc expression allocates a block of memory on the stack. A stack allocated memory block created during the method execution is automatically discarded when the method returns. Okay, that's good. You can't explicitly free the memory allocated with stack alloc. A stack allocated memory block isn't subjected to garbage collection and doesn't have to be pinned with a fixed statement. You can assign the result of a stack alloc expression to a variable of one of the following types. So there's span, there's a pointer type, and then I think there was something else. I don't remember. Avoid using stack alloc inside loops. Allocate the memory block outside the loop and reuse it inside the loop. Because the amount of memory available on the stack depends on the environment in which the code is executed, be conservative when you define the actual limit value. Okay. I don't think I'm gonna need to use this just yet. Okay, let's carry on here. Okay, where was I? Note, you can also stack alloc stuff yourself, but it can only be used in unsafe code. So I think that might have changed over time. Maybe, I don't know, because I am reading something that's from like 2015. Or maybe I'm just missing information, and I'll find out later that you do need to use it in an unsafe context. Okay, comparison. Struct needs to be Struct needs to compare memory the struct occupies. It needs to compare memory it occupies. Okay. Access. Fields in a struct can be enregistered. There's rarely write barrier cost on assignment since it's passed by value. Now, since it's passed by value, the copy cost can be significant. We have seen such cases. Okay. Yeah, if your data is like that big, then I can see there being issues there. I wonder if I'm like really just looking too much. Well, okay, no, to be fair, I'm not looking too much into this because, okay, let's just like think about this for a second. Okay, 20 bytes. It's going to be 20 bytes for one landmark position. I'm getting 30. Let's say I'm getting 33 landmark positions. Okay. That'll become what? 66? 660. Wait, really? This size was massive before, and now I've taken it down to 660 bytes by just switching to a more primitive method of packing and unpacking? Holy fucking shit, dude. That's kind of cool. It's a bit more of a headache to set up, but this is a kind of headache that I'm okay with dealing with because I like working with bytes. I need to see if doing I need to see if working with the bit converter class can cause garbage collection issues if it generates a ton of garbage, because like bit converter is supposed to be like they've probably done like a ton of performance optimizations, right? I believe, hold on, bit converter, C#, the C# reference is there. So CS reference, yeah, okay, CS reference. Reference, Microsoft.com, okay. You know what? Okay, we can try and open it here. Even though I don't think I'm gonna understand too much from it, because I believe there was like pointer stuff going on. Okay, so we're gonna open this up. This is the C# reference thing. Like you can open up, you can look up any of the types that you have, and you can read all the code for their methods and stuff. You can read the entire, like the code for the entire class. You can see all the fields, you can see all of the methods, all of the a bunch of things. You can see a lot. Okay, so bit converter. So there's a bit converter class. You're gonna open that up. In bit converter, we have, okay, let's do .get float. Isn't that right? Get float. Okay. All right. Project. No, does that say project? Project Explorer. Document outline. Namespace Explorer. Oh, I can change what the thing looks like. What happens if I search now? Oh, okay. All right. Get. Oh, there it is. That's what I was looking for. What is this called? Outline. Okay. So get bytes, get bytes, get bytes. Oh, I need to look at what? No, I don't need get bytes. I need to single, I believe. Oh, it's to. It wasn't get. Okay, that's why it wasn't finding it. Okay. Oh, wait, go back. Okay, give me a second here. Okay, so it all right, so at this point it's just checking. Hold on. What is going on here? Cuz like this sends the thing to int, but then it does a typecast. Okay. Yeah. I'm going to need to go and learn how like pointer stuff works in C# to understand what's going on here. Okay. So I'm wondering if I should do that now. Because like I would definitely love to be able to understand what can and cannot. Dude, this is just like, I think this is just like the one situation where I'm gonna need to worry about this so much. I'm also planning on working on like a soundboarding feature for my VTubing app. But like the soundboard itself is going to be elsewhere. It's going to be more of like a soundboard controller kind of thing. And I'll have it running on a different system. And then that is going to be sending JSON messages. But I'm wondering if I can avoid having to send JSON messages if I keep like a fixed, like if both sides know about the data, then like if both sides know about the data, because like one side is going to be sending messages, though. Okay, is I don't think I need to worry about it too much on that end, because if it's like triggering once every now and then, even if it's like once every few seconds or something, it's like it's a soundboarding thing. I'm not doing it like constantly, right? So I don't think that's going to be too much of an issue. I think we can make use of the DVTMP message protocol. That's a bit of a mouthful. Holy shit. Okay. Back to this. So for the heap, there are three aspects of WRT GC. How much you are allocating compared to the rest. You need to pay at least fixed cost for... Okay, we're almost done reading this. You need to pay at least fixed cost for each GC for suspension/resumption. If the I think this is going deeper into how the GC works than what I'm looking for. Is this info gonna benefit me right now? I would love to know how the GC works, but like the GC itself is a fairly complex system. So like going deep into how that works. Before doing that, I need to figure out if it's worth my time. At least right now. Because like on my own time when I'm not streaming, I can like just go off on tangents. I can like just go down a rabbit hole and keep on searching, and I'll lose like hours of my day just doing research, which is great. I get to learn stuff, but like if I start doing that on stream, then it's just going to be a whole lot of silence and me just jumping from one page to another to another. To be fair, that's what I've been doing so far. But like I do want to stick to the topic that I was trying to do research on. So yeah, I don't know if I should carry on reading this. Okay, I mean it's almost over anyways. Then there was another blog post by the same person. Okay. So let's see. They have some kind of analogy here. talking about a food court. When I first started working on the GC, my predecessor was explaining the GC tuning to me. I told him that I thought it sounded like how I saw janitors work at food courts. I frequented food courts at the time, and he concurred. What I said was, if you observe at a food court, in order to be productive, the janitor tries to collect a sizable amount of dirty dishes when they come out to collect, which means when they collect more often when it's busy. No, which means they collect more often when it's busy to not risk running out of clean dishes, and less often when it's not busy because there are very few dishes to be collected. This is the same way that the GC tunes. This is the same way that the GC tunes. The dirty dishes are like the space occupied by dead objects. Okay, that makes sense. It was used, i.e. dirtied, and can now be reclaimed. The clean dishes are like the cleared space GC hands out for people to use for new objects, etc. No, new objects, i.e. allocations. If GC does a garbage collection and didn't find much dead space, meaning high survival rate, it'll wait till more cleared space is used, or in other words, more allocations are made before it does the next collection. I think I should read this later on my own time. I'm going to leave this open. And I have actually read, in this, I've read this page. This was a while back, so like I can benefit from reading it now again, but I'm definitely not going to be reading all of this. But just the fundamentals, which I think is the same page, right? Yeah, it's the same page. I think I read this as well a couple of days back. Okay. Let's go into memory footprint. The memory footprint of the object. If the object is huge and frequently allocated, making it a struct would consume the stack much faster. Hence, I'd rather have it as a class. On the contrary, I'd rather avoid the GC penalty for small value types, hence make them a struct. Can you make the object mutable? I find structs great for value objects from the DDD book. Okay. Would you face some unboxing penalty based on the usage of this object? If yes, go for class. Okay, so it's seeming to me like I need to go for a struct instead of a class, specifically for holding this data. But then I'm not entirely sure if it's going to be giving me a huge performance boost. So I don't know if whatever I'm doing here is just like useless optimization, like pre-optimization. Okay, so this doesn't need to be serializable anymore. We can make this a struct. Alright, great. I don't know if this is gonna give an error somewhere else. Well, this is it's an array of the structs, right? So that should be fine. Then there's normalized landmark. That's another one. That should be a struct. And then for this also, I'd made a collection class. So this was all when I was doing like JSON stuff. Now it's not going to be required. Now what is pose landmark result? Oh, that stores like an array of both of them. This would be required if I was sending both. Yeah, if I was sending both, not just one. So, okay, 660 bytes would become what? So, take the 2 zeros away. Okay, 6612. Okay. Well, okay, fine. Just 66 plus 66. Why am I... Hold on. I want to do this mentally. 66 plus 66. So 6612. Add 1 on top. 66. It's not multiplied. It's added. Okay. I almost like doing mental math. I almost did like a cross kind of thing where you do how you do multiplication. Okay, so no, I don't have to do that. 6612, 1 on top, 6612, 13. So would it be 132? Yeah, so then it would be 13,002. Really? It's 660 and 660. It's supposed to be 1,300 something. But like, there's 2 zeros there. Why am I having a hard time doing this calculation? Hold on, dude. It's 1,320. Oh, you take away the 2 zeros in multiplication. I forgot that. Okay, fine. Anyways, 1,320. So that's 1.3 KB that I would be sending if I sent both the normalized landmark and the landmark, which the landmark would just be, it would be world position, and then normalized landmark would be image space positions. Give me a second. All right. So I'm probably not going to touch this right now. Maybe later on I could, like, if I see a use case for it, then in the raw messages I could like change things up a little bit. In the raw message I could add like an extra thing, so it would then receive a pose landmark result instead of just like a body pose landmark result. Well, no, I don't know if I said that right. I could change it up. I could add another magic number for a pose landmark result, which contains both types of body pose landmarks, instead of having just one landmark. For the time being, I don't want to send unnecessary data over the network, so I'm just going to stick with one. I still haven't managed to use the world space positions all that well. For the time being, I'm going to leave that. I'm going to let that be, because I don't really need it right now. Image space seems to be working out like okay. I have like basic hand movement and stuff going on. Just a second. Okay. All right, so back to what we were doing here. We could read this real quick. What was I supposed to be doing, dude? Fuck's sake. I was supposed to be reading up on span during this stream, and then I just got distracted. So we have memory, we have span. I'm gonna look at the ref struct. Like, hold on. You can use a ref. So this was introduced in one of the later C# versions, and I did see it at the time, but I didn't have too many use cases for it at the time, so I just let it go. You can use a ref modifier in the declaration of a struct type. Instances of ref struct type are allocated on the stack and can't escape to the managed heap. So you have a reference to a struct, but the instance itself is also allocated on the stack. To ensure that, the compiler limits the usage of a ref struct type as follows. Wait, this is interesting, dude. Hold up. Okay, a ref struct type can't be the element type of an array. Okay. It can't be the element type of an array. A ref struct type can't be a declared type of a field of a class or a non-ref struct. Can't be a declared type of a field of a class or okay. It can't implement interfaces. It can't be boxed to system.valueType or system.object. It can't be a type argument. A ref struct variable can't be captured by a lambda expression or a local function. Wow. A ref struct variable can't be used in an async method. However, you can use ref struct variables in synchronous methods, for example, in methods that return task or result. A ref struct variable can't be used in iterators. You can define a disposable ref struct. To do that, ensure that a ref struct fits the disposable pattern. Right, I don't think I'm going to be using this just yet. Okay, so we're gonna look into this. This is what I was initially supposed to be doing. Give me a second, let me hydrate, and then we can read this. All right. This article has been updated to reflect technical changes following its publication. That's good to know. That is good to know. Imagine you're exposing a specialized sort routine to operate in place on data in memory. You'd like to expose a method that takes an array and provides an implementation that operates over that type array. That's great if your methods caller has an array and wants the whole array sorted. But what if the caller only wants part of it sorted? You'd probably then also expose an overload that took an offset and a count. But what if you wanted to support data in memory that wasn't in an array, but instead came from native code? For example, or lived on the stack and you had a pointer and a length. No, and you, fuck's sake, and you only had a pointer and a length. How could you write a sort method that operated on such an arbitrary region of memory and yet worked equally well with full arrays or with subsets of arrays, and that also worked equally well with managed arrays and unmanaged pointers? Or take another example, you're implementing an operation over system.string, such as a specialized parsing method. You'd likely expose a method that takes a string and provide an implementation that operates on strings. But what if you wanted to support operating over a subset of that string? A string.subset could be used to carve out just the piece that's interesting to them, but that's a relatively expensive operation involving a string allocation and memory copy. You could, as mentioned in the array example, take an offset and a count, but what if the caller doesn't have a string but instead has a char array? Or what if the caller has a char pointer, like one they created with stack alloc to use some space on the stack, or as the result of a call to native code? How could you write your parsing method in a way that didn't force the caller to do any allocations or copies and yet worked equally well with inputs of type string, char array, or char pointer? In both situations, you might have to use unsafe code and pointers, exposing an implementation that accepted a pointer and a length. That, however, eliminates the safety guarantees that are core to .NET and opens you up to problems like buffer overruns and access violations that for most .NET developers are a thing of the past. It also invites additional performance penalties, such as needing to pin managed objects for the duration of the operation so that the pointer you retrieve remains valid. And depending on the type of data involved, getting a pointer at all may not be practical. There's an answer to this conundrum, and its name is span_t. System.span_t is system.span generic. Let's say that. System.span. System.span is a new value type at the heart of .NET. It enables the representation of contiguous regions. You know what I'm wondering? I'm wondering what is the difference between span and array segment? Because doesn't array segment also give you like a contiguous block of memory? Let me Google that, because I've used array segment before with like socket operations. Okay, C# array segment. Oh, there you go. Array segment versus span. How is the new span generic? How's the new span different from array segment? Oh, so span is newer than array segment. Okay. Span does not replace anything. It's value added. It provides a type-safe view into contiguous segments of memory, which can be allocated in many different ways, either as a managed array, a stack-based memory, or unmanaged memory. Array segment is limited to managed arrays. You can use it to wrap data allocated on the stack using stack alloc. Span allows you to do that. Oh, so span basically, it allows you to do what array segment allows you to do and then some. Array segment does not provide a read-only view into the underlying array. Read-only span gives you that. Span is not supposed to replace arrays. At the end of the day, it's just a view into data. That data has to be allocated somehow. And in the managed world, that allocation for most cases will be an array allocation. So you still need arrays. You should use span if you want your code to be able to manipulate more than just arrays. For example, consider a parsing library. Right now, to allow it to work with arrays, stack allocated memory, and unmanaged memory, it has to provide multiple entry points in the API for each of these and use unsafe code to actually manipulate the data. It also probably would need to expose a string-based API to be used by people who have their data allocated as strings. With span and read-only span, you can merge all that data logic. You can merge all that logic into a single span-based solution, which will be applicable in all these scenarios. Span is definitely not going to be something that's used by everybody and very often. It's a highly specialized part of the .NET framework, useful mostly to library authors and in very high performance critical scenarios. Okay, they gave some examples there. Okay. Requests can be done using span and stack allocated memory, which puts no pressure on GC, but you writing websites and services based on ASP.NET Core don't necessarily have to use it. Okay. So now I need to ask myself, what exactly am I going to be using this for that I wouldn't otherwise be able to do anyways, like, because like, okay, I'm going to receive the data, right? Hold up. Let's go to, we can close this. Let's go to this scratch thing. Okay. So I'm going to receive the entire payload, right? In that payload, oh, wait, I'm going to receive the entire raw message. The raw message will contain the magic number and the payload size, and then the payload data. Okay, so the magic number would be 1. The payload size is going to be, well, I mean, it's a bunch of bytes laid out, right? So let's say the payload size ends up being 660 bytes, because each landmark position would be a total of 20 bytes, because each float in there, and a total of 5 floats, each float in there would be 4 bytes. So each landmark position has 5 bytes. No, it has 5 floats, which is 20 bytes. Okay. Now 20 multiplied by 33, 660. So 660 bytes. I know the size, right? And I have that array to operate on. The only thing I would need to do is calculate offsets properly to feed into the bit converter class, to feed into the bit converter class's method. So where was that? Messaging system, some script. Okay, so here I have raw bytes, right? I have the payload size. It's reading in 32, so it's going to read 2 bytes. Okay, and then I'll create, well, payload data. I don't think I need to do that. So then I'm going to iterate over wait, this is a raw thing. Hold on. So I think I had written something else here as well, right? The payload data contains our body. Let's use tabs. Okay, so the payload data contains It contains our body pose message. Contains our body pose message. And the body pose message well, I mean, it's not a specific type. Like, I know what it's going to be. So the body pose message should contain, what did I define that as? So there was going to be landmark count and then the landmarks themselves. Okay. So landmark count and then landmarks. And then each landmark is like, this landmarks is going to be like one big array, right? But based on the landmark count, which, oh, there's a problem there as well. Well, I mean, no, it's not a problem. It's not a problem. Because like, okay, I could have given it, I could have given it 2 bytes, 4 bytes, I think. Int is 4 bytes. Yeah, I could have given it 4 bytes, but we are not going to have like hundreds of landmarks, at least not in body pose tracking. We're not going to have hundreds of landmarks right now, so there's no point in giving it that much. Okay, yeah, that works. So now back to some script here. So we will have the payload, right? For the sake of, yeah, I think I'm going to need to do the block copy operation. So buffer dot block copy, it's asking for the number of bytes, right? The number of bytes that I need is the payload size starting at the offset. So it's starting at the offset. So block copy array source and then block copy. Oh, it's a void operation. Okay. So I can create an array here of payload size. Oh, payload data. There you go. Right. So I want to copy it from raw message bytes. What is the offset? The offset is supposed to be 5, I believe. So 0 is a magic number. 1, 2, 3, 4. So then the offset is supposed to be 6. No. 0, 1, 2, 3, 4, 5. Okay, yeah, we're starting with 5, right? So, and then the array, the destination array is supposed to be payload data. Destination offset is 0 and int count. Count is supposed to be payload size, I think. I believe so. Yeah, it's a payload size. It's a number of bytes, right? The payload size is the number of bytes. Yeah. Okay. So then that's our payload data. Within the payload data, we would now have landmark count, which would be payload data that's the first byte, right? And then we would have another array. Now I don't need an extra array, do I? I can just start the oh shit. You guys cannot see what I'm doing. Hold on. I just realized that crap. Okay, let's turn this off. Let's turn this on. Let's turn this on. Okay, cool. Awesome. I think the music has stopped, probably a while back. Okay, let that finish and then it can carry on. Okay, so now the payload data is, it has been copied, and then we get the landmark count, and then based on the landmark count we run a for loop and decide how much data we're going to need, because landmark count would basically say that, yeah, how do I want to go about this? I would need to create a landmark object or a landmark array and just call it landmarks. Okay. Wait, do you need to initialize a struct before? I think you need to initialize it, right? Yeah, I think you need to initialize it. Cannot be used as a target type of new. Oh, it's an array. Okay. New landmark. Landmark count. Okay. And then okay. So we create the array and then we have to run a for loop. But the loop should start at 1 because we have our payload data. And then I is supposed to be less than payload data dot length. Then I plus 4. Does that work? Plus equals 4? Okay. So then we want to offset by 4 each time. So in each iteration, we're going to offset by 4. Is that really the best way to go about it? No. No, I don't think that's a good way to go about it. I mean, that's one way. But like... Okay, so let's say I do it a different way. Let's do I equals 0. Landmarks dot length and then I plus plus. Okay, so now here I would need to calculate the offset myself. Give me a second, let me hydrate. Okay, so here's what we can do. We can do payload offset. The offset can start from 1. And then we want to read 4 bytes each time. Okay, so we want to read 4 bytes each time. Right, so this is where the bit converter class would come in. Oh, wait a second. So then for each, maybe I should be running another loop here. Well, I could do that, or I could just have 5 big operations there. Okay. So landmarks I dot x would be bit converter dot to single payload data oh, hold on, maybe I should rename this payload data index. That's better. It's a bit long, but it's fine. So payload data index, and then what else? Oh, okay. I just need to pass this in, and then payload data index. All right. Can I fit that on the same line? No, I can't. That's fine. Okay. So once we've done that, we increment payload data index by 4. And then we repeat the same thing for this, and this, and this, and this. Okay. Oh, wait, I forgot one important part. It's this thing. Okay. So then that becomes 20. And it's going to keep going until the number of landmarks have all been decoded. Visibility and presence. Okay. And then it's going to carry on to the next, and the next, and the next, and the next. Okay. So now what I need to do is create a raw message. I think I'll do everything within the same script. I'll write like some debug logic. And where's the update method? Did I comment it out? No, it's down here. Okay. So I'll write some logic that that just sends. It'll directly call this method and send in the raw bytes. So I'll have to create the bytes myself. Yeah. I'll have to create the bytes myself. So what I'll do is I'll first create the array, populate the array with a bunch of the landmark stuff, and then send that over. No, then pack that information into a byte array, and then send that over to the other function, to the other method. All right. So if I have done this right, so we have landmark count. I need to look into if like these, the block copy operation, if I've done it properly or not. I need to look into that as well. Okay, so here's what I'm gonna do. Okay, I can do it within this, right? Yeah, I can. Great, cool. So we can create a byte array, BAR01 equals new byte. Oh, what happened there? Okay, there's an ad playing, so I'm gonna hydrate. All right, welcome back. Okay. New byte. Let's say 4. Okay, and then let's create a new thing here. Actually, can't I just? I think I can. I think I can initialize this like. 6. Okay, great. So then BAR02 equals new byte. Or we can do 3. And then buffer dot block copy copy it from BAR01, start at the offset 3, copy it into BAR02, start at the offset 0, and count 3. Okay. And then here I want BAR0, and then I can just carry on. Okay, 1 and 2. And then let's print it out. Okay, so let's go back into the VTubing, no, not in the VTubing app, back into Unity and see what's going on there. Give it a second. Unity is taking some time. Alright, in the meantime, I guess I can go back to this. Okay, so we are storing the information here. Assuming I have done this right, then this information can then be used. It should be usable. So I should be able to apply this information into onto, well, I should be able to apply, I should be able to use the data that I'm getting, that I'm unpacking, to set positions of cubes. Is Unity done? I'm not sure. It seems to be a bit stuck. On the bright side, thanks to some very helpful information from a person on Twitter, I started using assembly definition files. See, because I'd heard about assembly definition files in the past, I never really looked too deep into it. I kind of just knew that you could use it to like divide your code up into different segments. I did not know that it actually does help with compilation times. Because, dude, because of the compilation times, the iteration time between when I change some code and when I see the change being reflected in the editor, it is horrible. So like I could change one line of code and then I'll have to wait for a minimum of 30 seconds, if not a minute, before I can even use the Unity editor. And then, you know, I have to enter play mode and all of that stuff. So I started using assembly definitions to sort of divide up the code into different chunks, into different modules. And that way it only has to compile the files that are within that assembly definition file. It only has to compile the files that are part of that specific assembly. So I've now divided the code into multiple assemblies. And it seems to be helping because it's not trying to compile like all of the code all over again. It seems to be a little faster than what it was before. For now, I'm just waiting for this thing to do its thing. You guys can't see the editor. I just realized that as well. I'm wondering if I should have done this in like a bare bones C# application. I'm wondering if that would have accomplished more. I could still do that technically. I hope IntelliSense works, because like then I don't need to have the Unity editor open at all. I can just close the editor. Okay. I think I can go for this project, learning async. Oh, okay. Wait a second. So it is asking me if I want to save this file. Maybe I can save this to do, and the rest, I don't need to save it. Usually I don't have this issue, but like, is there some other file that hasn't been saved, which is why it's not allowing this? I did have like scratch notes. Do I have the scratch notes here? No. Okay. Let's bring it down here. Let's say scratch notes. Okay. Save this. Go here. Close. Close. And now, so I might need to rewrite that code again. But yeah, we can do it. It'll be much easier to like test things out. So it'll be, the iteration time will be a lot better. Wait, is it still capturing the window? Yeah, it's capturing the window. Okay. All right, so I can get rid of all of this for now. Or I can just comment it. That works too. Oh shit. What is that? Okay. Right, so byte array bar01 equals new byte 6 0 1 2 3 4 5. Byte array bar02 equals new byte. Okay, and then buffer. Oh, is IntelliSense not working? Maybe not yet. Okay. Should I try restarting? Okay, let's try. Let's try restarting the language server and see if that helps. But in the meantime, buffer.block copy. I think I have it open here. Okay, so here are the arguments. So we had the source array, source offset, destination array, destination offset, and count. Okay, cool. So let's do that. Offset 302. Oh, are we good? Hold on. I think we're good. Hold on. Give it a second. Give it a second. No, we are not good yet. Now we are good. Okay, great. Cool. Awesome. So, what is the next? I think it was offset. So let's just do 0 and then count 3. Okay. So now that that's done, we can do string s equals this 02 0. Okay. console.writeLine. Gee, I had that method, right? Yeah. All right. S. Okay. Man, Unity is still doing its thing. It's still like doing its loading thing. Is the music still going? I believe it is. Yeah, it is. Okay. Okay, so the VS Code window is also kind of stuck right now, so we're just gonna wait because Unity is still doing its thing, and I think that's kind of oh wow, okay, all right. Okay, we are just waiting now. Okay. Oh, there it is. So we know block copy works. Great. Now let's try the same thing with a float. Okay, float f1 equals, oh, Unity popped up. So Unity is done with its thing. I don't think I need Unity anymore. So we're gonna carry on with what we are doing. Okay. So let's say 0.5, right? It's gonna be 4 bytes. So let's do byte array equals no, byte array BAR03, or let's do BF AR01 equals new byte 4. Do I need to initialize it like this? Can't I just do bit converter? Dot get bytes. Does it need an initialized array? I don't think it does. The number to convert. These are all like single. Okay, yeah, great. Okay. So float. So that's converted. Once it's converted, I want to copy that. Oh, wait a minute. What if I want to do 2? Yeah, what if I want to do 2? So let's make it 8 bytes. Okay. And then float f2 equals 1.2f. Okay, how does get bytes know exactly where it's supposed to copy this into? Because like it's not asking for an offset. It's not asking for a start point either. Okay. Is there a different method that we can use? Let's just get bytes. Okay, all right. So if that's the case, then I would need to... Yeah, okay, hold up. So here's what we can do. Let's make this for F1. F1 B array. And then this can do this can be F2 B array. Or I could just call it FB array. Right, I could like reuse it. And here I can put F1. I can also create another byte array here, which would be, let's just call this, I'm having a hard time, I'm getting hung up on the fucking names, dude. Okay, so let's do 8, fine. And then here I could use block copy, right? Buffer dot block copy. And here we have the source array, which is FB array 01, at the offset 0. And we want to copy. Oh, so this is a good use case scenario for okay, let's carry on. So, what is it? Source offset. So yeah, this is a good use case scenario of like when I'm gonna have multiple floats, and I wanna, or well, it's a good use case scenario for when I wanna choose an offset in the destination array. So in this case, what is it? BAR03. The offset here right now would be 0, and so I want to count 4. But then later on, the offset is going to be something else. So then I can change this. Right, we reassign the value here. So now we are kind of converting F2 into bytes. All right, and then we want to start at the offset 0, but we want to place this at the offset 4 and then count that many. Okay. So 0, 1, 2, 3, that's 4. Okay, yeah. All right. So now let's create an F. Oh shit, I'm going to have to store the value again. Okay, all right. So let's do what? FB array O1 equals. Wait a second. So let's run a for loop. So let's do string s equals this, and then for int I equals 0, I less than FB array O1 dot length. Okay, s plus equals okay, and then that. All right, so then we write this, and let's just see how well that works out. Do we get any errors so far? No. Why are there only 4? Oh, that's why. I'm reading the wrong array. Okay. Let's change this up a little bit. Let's do 3.5 and let's see if something changes here. Yeah, it did. Okay. And this is interesting. So if we look at these, this is in little endian format. So like the order gets reversed. So, okay. All right, cool. Awesome. So now that we have this data, we can try and decode this exact same data. So we can do, we'll do another buffer block copy. This one is going to go from the array, from the big array at the first offset. So we want to do F1 first. Okay, so at that offset, and we want to put it into AR01 at that offset, and we want to count 4. Okay, so then let's do float F3 equals bit converter dot get single, no, to single. What was it? FB AR01, and then we try to print it out. Let's see if that works. شاهد الفيديوهات بدون إعلانات أو إنترنت مع إمكانية تشغيلها في الخلفية. جرب يوتيوب بريميوم مجانا. Awesome. Awesome. That works. Great. So now we can do the same thing again here. We can have an F4, but this time we start at the offset 4 over here. Oh, forgot to do this. So let that finish executing, and then I need to run it again. Now it'll be proper. There it is. Awesome. So we know that this works now. Great. Okay. All right. So, okay, as much as I would love to continue, I'm gonna have to end here. I will carry on working on this off stream, and I'll try to stream again tomorrow. But yeah, that's gonna be it for today. I'm gonna raid this person, somebody named I Am Terrific. Okay, so yeah, that's gonna be it for today. I hope you guys have a nice day, and I will see you all next time. Peace.